Homework for this week, we are factoring polynomials. We've done a bit of this in class, so hopefully this format is familiar, x squared plus bx plus c. So this means that we have a coefficient of 1 right here. Okay, so this is what I like to call unfoil. When we take a trinomial and we break it into two binomials as factors. A polynomial with 3 terms is called a trinomial, as shown above. Trinomials can often be factored and written as the product of 2 binomials. To help us factor trinomials in the form x squared plus bx plus c, multiply the binomials in a and b and look for any patterns. Okay, so we're going to distribute these. We're going to do our FOIL. The first 2 terms, x times x gives us x squared. 2 times x gives us 2x. 5 times x equals 5x. And 5 times 2 gives us positive 10. We could combine like terms and get this trinomial right here. How does the middle term of the product relate to the binomials? Okay, so how does this 7? So the 7 right here is the sum. It is the sum of the second terms in both binomials. Okay, so this 7 right here, if you look at it, it's the sum of the 5 and the 2. The 5 and the 2 are the second terms in the binomials. The x would be the first term. The 5 and the 2 are the second terms in both binomials. So the 7 is the sum of those. And then how does the last term of the product relate to the binomials? How does this 10 relate to these 2 binomials? We can say that it is the product of the second terms in both binomials. Okay, so let's do another example of this. For b, let's go ahead and distribute. Let's do our FOIL. We multiply the first terms. Remember, FOIL means first, outer, inner, last. Or you could just think of it as distributing the first term and then distributing the second term, however you like to think about it. But we're going to get x times x is x squared. Negative 3 times x is minus 3x. 7 times x is plus 7x. And 7 times negative 3 is negative 21. Let's combine like terms to get x squared plus 4x minus 21. Okay, how does the middle term of the product relate to the binomials? How does this middle term relate to these? Remember, this is the sum. So instead of writing this twice, let's just take this answer and write same answer. Same answer as last time. How does the last term of the product relate to the binomials? So how does this negative 21 relate to these binomials? It's the product of the second terms. It's the product of 7 and a negative 3. And this is going to be same answer. Moving down, Abigail needs to factor x squared plus 11x plus 30 using the patterns above. Describe what should be true about the values in the binomial factors. Sorry, I'm just reading the question one more time. We can say that the second terms in the binomial factors have a sum of 11 and a product of 30. So with our vocabulary, first check to see if GCF can be factored out. That should be step number one always. Check to see if there's a GCF. Next, find two factors with a product of C. You might be thinking, what's C? C is that constant by itself. Find two factors with a product of C and a sum of B. B is that middle term or that second coefficient. Use these two values to write your binomial factors. Follow the steps above to factor each trinomial below. Check your answer by multiplying. Okay, they want us to just break it up into small baby steps. What two factors have a product of 6 and a sum of 5? Hopefully by now the whole class knows how to do this, but these are the steps. So what are the factors? Okay, the factors of 6 would be 1 times 6, and there's also 2 times 3, and there's none else that I could think of for 6. Yep, that's it. All right, and then what would give us a sum of 5? Wait, hold on. The factors of 6 would be this. Okay, looks like we have to, go ahead and just factor it. Okay, so we're gonna have x in here, we're gonna have x in here. What multiplies to give us 6, but adds to give us 5? We go x plus 2 and x plus 3. Okay, so our sum has to be 5. 2 plus 3, which gives us 5. Okay, I think that's all they're asking for. And then what's our final answer here? Sorry, the table kind of threw me off, but as long as we get the same final answer, x plus 2 times the quantity, x plus 3. And that's it. Okay, this is what we've been doing in class. I think we did the examples like this at least a dozen times. But what else can we do here? How do we check this? Once we factor something, we check it by distributing. So let's distribute this out. X times x gives us x squared. 3 times x gives us 3x. 2 times x gives us 2x. And 2 times 3 gives us 6. Okay, combine like terms to get, and this is the exact same trinomial that we started with. Okay, and let me walk you through a little bit on the back of this. Factor the trinomials in 3 through 5, then reflect on your solutions in A through B. Let's set up our two binomials. Can we factor out a GCF here? Nope. So we're going to put x in both binomials because x times x gives us x squared every time. And now what will multiply to give us 8 but add to give us 9? We can use 1 times 8. Okay, 1 times 8 gives us 8, but 1 plus 8 adds to give us 9. All right, that's our answer. I should have wrote it down below. Here we go. Okay, so do the other ones just like that. And at times, there are no factors of C with a sum of B. What happens then? When we can't multiply something to get C and also add it to get B, what happens then? In this case, the polynomial cannot be factored and is a prime trinomial. That means we can't reduce it. When it's prime, we can't reduce it anymore. For 6 through 8, factor if possible. If not possible, explain why. Let's factor this one. We've been here before. We've done this before. We got m times m. What multiplies to give us 14 but adds to give us -9? Okay, I gotta think about it for a second. Okay, we could take 7 and 2, yeah. Negative 7 times a negative 2, yes. These two, negative 7 times negative 2 gives us positive 14, but when we add these two integers together, we get a negative 9. Okay, and remember, if you're not sure about your answer, you can check it by distributing. Let's do one more together. Okay, we're gonna split this into a binomial pair, and we're gonna have x times x. What multiplies to give us positive 1, but adds to give us negative 5. Let me do the light dance. Okay, I was looking at this, and the only factors of 1 are 1 times 1. There's no way we could take 1 and another 1 and somehow get negative 5. So this is prime. Let me cross that out here. This is prime, not factorable. Okay, and let me just highlight that here. Okay, so get your practice by doing those other few examples I did not go over, and we'll move on to the next one in the next video. Thank you.